Welcome to Fueling Conversation. My name's Allie Sylvester, Director of Business Solutions at Flogistix, and today I'm joined by our Vice President of Petroleum Engineering, Todd Moehlenbrock. I'm excited for today's episode because we're going to be talking about something that we refer to as the carbon capture calculator, but that is quite a mouthful, so we also refer to it as the emissions calculator. Todd has been a primary stakeholder on this project, working with our product development and software development team over the last year or so. So, Todd, let's talk about the carbon capture calculator. Why is Flogistix developing this emissions calculator?
Okay, well, thanks for having me here. I'm pretty excited to be part of this podcast. I think it's a great idea, and I think it's a great way to get information out to a lot of different people. So, the Flogistix oil and gas customers are under ever-increasing regulatory demands and public scrutiny to reduce their greenhouse gas emissions. The emissions calculator will provide transparency to the benefit of the Flogistix vapor recovery process on reducing these greenhouse gas emissions. So perhaps I need to give a brief description of vapor recovery just to kind of level set everybody. Flogistix compressors are uniquely designed to capture vapors from oil stock tanks. As oil wells go to production facilities for processing, they typically enter one or more vessels, such as a separator or a heater treater, and this is done to segregate the oil from the water and the gas. These vessels operate under pressure, such as 50 psig, and when oil is dumped to the stock tanks, there is a pressure drop, and the lighter hydrocarbons off of that oil will flash off the oil, creating hydrocarbon vapor and increasing pressure in the stock tanks themselves. Our compressors pull off of these vapors from the tanks to manage the pressure inside the tanks. These vapors are then routed to our VRUs and compressed to higher pressures so that they can then enter the gas sales lines to be processed downstream. We can also attach these VRUs or our compressors to the separators themselves or the heater treaters or vapor recovery towers. Every facility is somewhat unique, and so we're able to design these as the facility needs. Our customers can use the emissions calculator to demonstrate their environmental stewardship by using actual data from the emissions calculator to communicate to their investors at board meetings, at other internal or external public-facing events.
Yeah, no, that's super interesting. I've had the opportunity to work really closely with this emissions calculator as well, and it's something that is accessed by our customers or, through our team in Flux, which is a flagship product, really the platform of Flogistix and how we monitor the fleet and do operational analysis. This carbon capture calculator has allowed for us to see when the unit is in peak condition, it is eliminating or avoiding a certain amount of emissions, which is a great place to see that. So what is the calculator actually measuring? I hit on it a little bit, but can you explain that a little bit more?
Yeah, so the calculator is baselining the environmental impact of capturing these hydrocarbon vapors off these stock tanks that we talked about using our VRU process, and it contrasts that with the emissions, the CO2 emissions that's created during traditional flaring operation. The output is the amount of metric tons of CO2e or CO2 equivalent.
Okay, so why is it that we're baselining against flaring?
Well, we use the flaring because current regulations prohibit venting these tank vapors. So they have to do something with the vapors. So the regulation does allow operators to either flare or capture these vapors. When these vapors are combusted in a flare or combustor, the resultant hydrocarbons combine with oxygen in the air, and the byproducts of this combustion are heat, water vapor, and CO2. It's really eye-opening on the amount of avoided or abated flare emissions a VRU can provide. For example, a typical Permian Basin facility where our VRU is capturing 300 MCF per day of tank vapors equates to about 45 metric tons of CO2e every day. In fact, in 2023, Flogistix VRU fleet of over 3,000 compressors avoided over 14 million metric tons of CO2 equivalent, a huge number and a real benefit to our environment.
Yeah, that's crazy.
So I think it's important for our customers, public, and other stakeholders to know the impact that the VRUs have on the environmental stewardship, and what better way than to provide the actual data itself.
So I mentioned Flux, the proprietary platform where we analyze and operationalize our fleet. How does this carbon capture calculator work and fit into that platform?
Yeah, so the emissions calculator is an additional feature, as you mentioned, to our Flex platform. And this allows a user to view, analyze, and manage our Flogistix compressors. So the calculator does require two main components, and those are the vapor volume that is actually captured by the VRU and the composition of the tank vapors themselves. The vapor volume is measured by our proprietary virtual flow meter, or VFM. So I'm not going to dive into all the details of the VFM today. That could be a podcast in itself. But I will say that the VFM is not a physical meter, such as an orifice meter that we see all over the oil field today, but rather it estimates flow rate based on a number of data points collected from the VRU's programmable logic controller, or PLC, such as driver speed, gear ratio, elevation, and a number of other factors. It is not meant to be custody transfer grade, but the rigorous testing that has been done has proven it to be highly accurate. The other component for the calculator is the vapors collected from the oil stock tanks, or in some cases, vapor recovery towers, heater treaters, or separators, whichever vessel the compressor is connected to. These vapors or gas is collected at these vessels and sent to the lab to be analyzed. These vapors analysis will determine the mole percent for each of the hydrocarbons in the vapor from methane through hexanes. It will also show the percent of impurities such as CO2, H2S, nitrogen, and oxygen. So knowing the percentage of each of the components in the vapor and the total volume captured, we can then calculate the amount of CO2 that is generated through the combustion in a flare stack. We do take into account the efficiency of the flare stack, and we also calculate the emissions from the compressor driver itself, be it either a gas engine drive or an electric motor. And so we use that and we come up with the net emissions abated by subtracting this driver emissions from the total calculated emissions. The emissions calculations and factors are based on the American Petroleum Institute, or API 2021 Compendium of Greenhouse Gas Emissions Methodologies. That is a mouthful. And also from the IPCC, or Intergovernmental Panel on Climate Change, their 5th assessment report, and also the EPA eGrid of 2021. So all these calculations are based on industry and government standards. The emissions calculator allows the user to choose different default time periods to view the amount of abated emissions, such as the last 28 days, the last week, or the last day.
There's a lot going on there. I have had the privilege of working pretty closely with you over the last several months to iron out the details of this carbon capture calculator, and I believe it's in a pretty good place, but there's probably some more to be done. So explain to me some of the challenges with this emissions calculator.
So, we're striving for accuracy, and I think the biggest challenge to accuracy for the calculator is centered on the vapor composition itself. So typically when we collect vapor samples, it is a snapshot in time. Vapor compositions are not static and exhibit a range of phase behavior that affects the percentage of each of the hydrocarbon components, which has a direct impact on the emissions calculation. Such things as temperature variation from day to night or from winter to summer, upstream separator and heater treater temperatures and pressures, changes in the oil coming from the well as it ages, changing well counts that go to the facility, all can have a major impact on vapor compositions. So we are investigating other ways to use what we call equation of state models, such as PROMAX, that will help with accuracy of these compositions as well as the frequency of collecting samples. It really all depends on how accurate we want to be.
That makes sense. I know one of the things that we've done recently with the development team is that we have started the prototype with a standard gas composition analysis and have since evolved that to accept variations of that gas composition analysis. What are other future plans for this emissions calculator?
Yeah, so as you mentioned, we are coming up with version 2, I guess we call it, for the calculator. And so we would like to be able to input gas compositions for individual assets or facilities themselves if they're available. We're also looking at updating and enhancing the time period selection. We currently have that limited default time periods that we talked about before, but we would like to upgrade to a calendar-based period selection. So another update is reporting aggregation. We want to be able to aggregate the abated emissions by different groupings of our VRU assets themselves. So internal folks can look at their areas that they manage, or our customers can look at their Flogistix fleets to see their total emissions that's being abated. We can do it by field or states, VRU models. There's numerous ways that we can aggregate, and we're kind of stepping through that right now to do what we think makes sense. We also want to include the natural gas liquid volumes themselves. So this is a natural progression of this. Since we have the gas composition and the volume of the vapor, we can break out the different NGLs such as propane and butane and hexane and calculate the number of gallons that we collect in a different time period. We think that would be very helpful for our customers. And lastly, we want to be able to calculate the BTUs that is saved from flaring during a selected time period. The amount of energy that is saved or abated by collecting these vapors is tremendous, and it's such a waste of good energy that could be used for good purpose.
It seems to me like there's a little bit of the economics of a vapor recovery unit, right? These NGL volumes, calculating these BTUs saved, is really just a justification to show the value that these vapor recovery units are bringing if for any reason you weren't already sold.
Yeah, so you're exactly right. These NGL volumes are very valuable, and the operators make good money off of collecting these vapors, and so why not collect them and reduce emissions at the same time?
Do you think that there's been any concerns about the fact that we have a virtual flow meter, and what are our plans around the virtual flow meter?
Yeah, so as we mentioned, a virtual flow meter was never intended to be sales transfer grade, but it is accurate. But it kind of depends on how accurate we do want to be. So we are also investigating installing a physical meter on our skid to be able to more accurately measure the vapors that our VRUs are capturing. Besides providing more accuracy in the volumes captured, we can also use this information to help refine and calibrate our VFM itself. So I also want to bring up that we have been exploring the carbon credit markets and whether or not the abatement of CO2 equivalent by using our VRU process would qualify for carbon credits or carbon offsets. The emissions calculator will be foundational to carbon credits. We are also investigating the use of blockchain technology to memorialize all this information and data to be used to calculate the metric tons of CO2 equivalent abated using our VRU process. And the idea behind all that is then we could somehow market, if we can find a market for these carbon credits, that we could help our operators offset some of the costs that they have on our VRUs.
I know that I've had the privilege of working with Danny Burrows, our Vice President of Software Engineering, as a part of this project. And I'm really looking forward to bringing Danny onto the podcast and maybe the three of us having an in-depth conversation about what tokenizing this emissions calculator could look like and what does that mean if and when we find a market. I think it could be really interesting.
Yeah, I truly think the blockchain aspect of it is something that we can definitely figure out. But the way the carbon markets are today, it's not quite ready for us, right? There's some resistance to fossil fuels and the oil industry of creating carbon credits. But I do think the world is changing. And so we are also looking in foreign markets as potential areas that we could sell these carbon credits. And then some of the recent regulations that we have just received from the EPA, we have a lot of marginal wells that are at risk. And could we possibly use credits to help subsidize VRUs to reduce their emissions so they won't be out of regulation and in violation and therefore continue to produce, which would be huge for our country and communities.
I think it's really interesting talking about this carbon capture calculator in light of the recent regulation changes, the methane rule that went into effect on the 8th of March. I'm hopeful that these emission calculations can help encourage or validate the value of a vapor recovery unit. And I'm even more excited about the potential for what a carbon market could look like. This episode really does have so much information, and this carbon capture calculator is really complex, but it's been a real joy to work with you on this. So thank you so much for joining me today, Todd. I look forward to more of these conversations.
Well, thanks for having me.
Thanks so much for tuning into this episode of Fueling Conversation. As always, you can find us at flogistix.com or on any of our social medias at Flogistix.